Welcome to a lesson with Dr. Powell. Let's take a look at an example of graphing a polynomial. Suppose that we have f of x equals negative 2x plus 5, and suppose that's cubed times x minus 1 x minus 1 squared. Okay, suppose we have something like this. All right, well, what's the leading term? Okay, well, think about these factors. Negative 2x plus 5, negative 2x plus 5, negative 2x plus 5, x minus 1, x minus 1. Take the leading term of each factor. Multiply them together. We get negative 2x quantity cubed times x squared. Okay, well, in other words, negative 2x times negative 2x times negative 2x times x squared. So notice you have x, that's x cubed, and an x squared gives you an x to the fifth. Then you have a negative 2 times a negative 2 times a negative 2. That's like saying negative 2 cubed, because exponentiation represents repeated multiplication. And whenever it does that, you can freely distribute across that operation of which it repeats, just as you can see here. So negative 2 cubed, or negative 2 times negative 2 times negative 2, is negative 8. So we get negative 8 times x to the fifth. And that would be the leading term. So we think, okay, what's the end behavior? Well, if we put in a negative here, we have 5 negatives and another negative. That's 6 negatives, be positive. Looks like if we're far to the left, so negative on the input, we're outputting something positive with 6 negatives. So that would be up. So an end behavior of up on the left and on the right. Let's see. We plug in a positive number into this. This is part's positive, but then there's a negative, so we're going to be down. So we're going to be up, down. You could even check this on your calculator if you wanted to graph that. You'll notice the graph will eventually be up and then go down. Okay, so using that idea, let's proceed. We know what the end behavior is. So then we know how to start our graph when we draw it. Okay, so we know we're going to start up and then we're going to go down. Where do we go through? Well, let's see. We set this equal to 0 here, and we notice we get so negative 2x plus 5 equals 0. So we get negative 5 is negative 2x, and x is 5 halves. So we have 5 halves, and this one is 1. So we know we have 5 halves, and we know we have 1. And we know we're starting up and we're ending down. Okay, so as we start up, we go down till we hit first sky, which is 1, and we know it's going to look a lot like a bounce. It's going to be a bounce. Okay, so it's going to bounce. Then we're going to come back down to this. Now, how does it look when it comes down here? It's going to behave like a cube, kind of go like that, and go down. So this would be the graph, something like that. Now, what about if we had something like x to the 7th? X to the 7th actually looks a little like a cube too. In fact, anything with an odd power other than 1, x to the 1 looks like a cube where it momentarily flattens. So if I were to have changed this particular function, so it was a 7 here, honestly, it would have looked a lot the same, even if you added in 4 more factors here of this. Well, you had 4 negatives, and 4 negatives here wouldn't have changed the end behavior at all. So we would have ended up having the exact same graph. You can go ahead and check that if you really want to, as I guess, an exercise for the viewer. But at least for this case right now, when we're dealing with the cube, that's the graph. Thanks for watching.